Hi guys, I hope you're good since last video. RAG, structured output, nodes functions, agent tools, graph components, multigraphs around the app logic that we can use depending on what user wants. Here we are going to use the same business application and have an extra graph that will be more advanced compared to the ones that we used before. That is why we're going to focus on this special graph to show what kind of workflow you can create for businesses that need, like in our example here, safe code execution. So we're going to be focusing into the code creation and code execution on all the steps that we want to implement. We will have users making requests, but we will put in the prompt something to trigger this graph especially. So there should be a request to make a script or something like that in the prompt in order for this graph to start. And after we're going to use a sandbox environment to execute the code. The scenario here, just put yourself into this scenario. The organization have some services available through different internal APIs, like safe ones. But we will be using some open APIs from the internet to simulate that. The graph agents are going to work together to create the code, the requirements, the Docker image executed, and return the answer coming from those APIs. If you love amazing UI with effects and some impressive visuals that will blow your mind, I want to tell you something. Everything will be pure backend on terminal output and focus on the steps with logs that shows what is happening behind the scene. Therefore, you can take off your 3D glasses. Let's start. Please watch to the end and like and subscribe. Architecture focus on advanced graph. So that's what we had before. In the previous video, we had a multi-graph application, and here we are going to add one extra graph to it. So still connected to this application business logic. And this one will be triggered by our prompt. The code execution graph, that's what we're gonna add here into the system. So this graph will be more complex than the other ones. And we're going to focus on this one only here. I'm just going to get rid of all those colors, make it more simple to understand. All right. So here I got the graph, the code. Those are the APIs that I'm going to use. But to get all of those edges, conditional edges and nodes, agents and everything, before writing anything, I need to draw something. So we're going to pass through the architecture first. That's what I suggest you to do. Have the visual, and after you can code. So we're going to go through this visual in this first part of the video. The user makes a request to the business application logic, which is going to be, it's just going to be getting the user. I'm just going to move this arrow because it has to come here. Okay, so the user makes a request. Business application logic side is triggered. This graph is started. And here we have different stages. We have here the conditional edges. All the graph nodes will be in the middle, and the tool nodes, and the sandbox code execution will be down there. I just have separated everything to make it easy to understand. We get the user input. We go to the conditional edge from the beginning. Code request, document or URL. So if it is a document URL, it's going to go back to the intergraph, go back to the business application logic, which is going to start the right graph. And if it is code, so here I'm just going to put this here like that. So if there's no request to make a script, this graph is not going to actually even start. But we never know. If the request goes in, there's a first node. The node is going to handle the query and see if it is qualifying, if it qualifies to keep going and create a code and everything. Otherwise, it's just going to exit that graph, go back to the business logic, which is going to handle the request to launch another graph if needed. Get the user input. And after the user input goes to this conditional edge, we have a code request, the tool nodes. The tool nodes, it's a tool API to choose which agent is going to be started. Tool agent decide which API. And after we find the documentation online, this is a search node, internet search. So it's going to choose the search. And it's going to go here. Don't look at the colors for the moment. Those are the retries. So tool search result. So we have the internet result here in this node. After we have another. So after having found here in the tool nodes, we use the tool, we get the output of the internet search, the documentation writer. After there is a conditional edge to evaluate the document. Is the documentation good in the conditional edge? Or is there any error in the documentation? Any error is going to go to the error node. Documentation step evaluator and the documented judge. So there's a judge for this documentation. Rewrite the documentation or execute it. If there's an error, it goes to the error exit. Otherwise, it can also retry by writing the documentation again, or it can go online to find some more information. So that's why we have those colors showing the retry steps. And I'm using an environment variable for that has a maximum retries. Normal routes and the optional routes is just to say what are those arrows. Okay, so we are here, we evaluate the documentation, and after we rewrite the documentation, after that we're going to use parallel nodes execution. So those nodes are going to be executing YAMA 3, 8B, 70B, and Genma 3, 70B all together, and we're going to gather the output of those ones here. So we're going to get 3 different code scripts. We're going to evaluate the script, conditional edge. Do we need to rewrite it? So is there any error first? There's no error. Otherwise, we're going to go back to the step before to create the code. If you need to create the code, and here I'm just going to show the retry route. Just going to put the dots. Same here, using an environment variable for this retry loop. After we create the requirements, we choose the code to execute. So out of those codes, which one is going to be executed? If there's many, or if there's one or so, we create the requirement or not. So, or there's an error, we need to handle the errors like crazy. It's very important. And create the requirement for the code. And after here, conditional edge, execute the code or not. So can we execute it? Or is there any error? We can execute it. We execute the code. How do we do that? We're going to go deep down here into our levels to the sandbox for code execution, which is a Docker container sandbox code execution. So there's a lot happening in this code execution. It's going to create the container, all the files, and it's going to be executing it. Success in execution or retry. So we have the error route or the success code execution management. Successful code execution management. Or we have an error analysis, also optional route. So there's a node which is going to be checking that standard output. If it is a standard error, it's going to be going into that error analysis. So different kind of errors. If it is coming from a try except on this an exception which is not related to the code, at this time it's going to go to it's going to be flagged as an error to exit. Otherwise, here we have the success, or we retry, or we go to the error analysis. So there's different routes. We re-execute, or we return an error. So same here, we return an error, or we're going to go and re-execute the code. So maybe there were a problem right trying to execute the code. We're going to try again. So here we're using same environment variables, which have a set number at the beginning. And it's going to be decreasing as the graph is retrying. Okay, so we got the full graph explained. That's all what we're going to do here. So I'm not going to go through the code in details. We're going to go and run the code and check the logs. APIs. Just let's check the APIs that we are going to gather. Edgify API. So here you provide a name and you get the edge in function of the name. So depending on the name, you get the edge. It's the hardest, this one, because there's a parameter. After here, we have the joke API, which is just returning random jokes. Okay, we're going to use this one here. Okay, you see you get random jokes returned. And we're going to use a dog API, which is this one returning dog pictures. So random dog pictures. So those ones are pretty easy because it's just an API call. So I'm going to flag those as easy. While the Edgify one, as it has the name, you see here, this can be tricky and you can get a lot of errors from the agents. So let's just flag this quickly. Just fast forward this, easy. This one hard because input variable. Okay. So those are the APIs that you have in your organization that are closed and that we're going to use. Please like and subscribe. The break is done. Success, edge, by name. We start straight away with the hardest one. How can I help you today? We put the prompt. I need an API call to be made. Oh, my friend. Her name is Junko. After the code is going to run. So I'm not fast forwarding anything from here. You're going to see how long it takes to run all those nodes. And you're going to see some of the outputs. We are going to go through those logs together to see what are the steps that has been taken. We're going to see also maybe an error. I will see. So here the Docker container is being created. The image is created. Execution one is done. So don't look at what is coming down here. I'm not using the business application logic, but here we have the success in the execution. The age of your friend Junko is 56. Okay, 56. And here I'm just printing the last 3 messages at the end. This is just the InteGraph node, the one returning to the business application logic. And here just ignore what you see at the end. So we launch the app. You can read the prompt now. I need to make an API call to get the age of my friend based on her name, which is Junko. So we put that like that. So you're going to see in the tutorials, we're going to be in Japan, and they're going to be Shibuya, Mangakisa, Junko, and that's how it goes. And here we have saved the query as an environment variable. After we get structured output that we've seen in the videos before, just to check, is there any code request, document request? There's nothing. If there's something, it's going to write something at nothing, PDF or URL. So if there's any document, it's going to say if it is a URL or PDF. So here we get yes for the code, yes for the code. Okay, so now we can start the graph. We start the graph. Tool API, choose agent. So this one is going to choose. It's going to choose here Agify. That's the one. So it could recognize it. The parameter is passed properly. With the escape, right escape, it's a right JSON, it's a good JSON. Formatting. After here, I'm just printing the templates of the prompt that I've sent. So in the prompt, there are the choices of APIs. After the user requests. So we can see here the jokes. We can see the Agify on the dog image. After find documentation online agent, which is going to use the internet search tool. It's going to prepare everything. Choose the right tool, prepare the query. The query is very simple, how to make a Python script to call an API and get the response. So that's the first step here. Okay, confirmation of the tool call. After we have the internet search, so the tool search node have fetched an answer from the internet. So we're using the same tools as you've seen in the previous videos. Previous videos we went through the code, so you know that it's a DuckDuckGo that we're using here. So it might return some errors sometimes. That's why it's not 100% application is going to work at every single run, but I'm going to talk about this at the end. So at the end, please stay to just listen about what I'm going to say. And here we get the documentation, but I want it in a JSON format. Document writer. So we have a judgment here saying going to quality judge. So document writer first. We're going to use the documentation to write. We have a template here for the prompt. So we're just going to give it everything. The user initial query, the documentation, the internet search, documentation, and after it's going to make a documentation. We say in the we need instructed LLM to create a Python script. I need to make an API call, but I just want the documentation. I don't want the script to be made. So that's what we precise here. So here you can see the retries. We are at 7 out of 10. So generally, that's I'm going to talk about the statistics at the end pretty quickly. So here, success generate, the documentation step evaluator, the judge says that we can generate the code now. So now I'm asking for the script. In the prompt, we will put the documentation, we put the user query and ask it to make a script. So here are the parallel nodes, 3 different nodes running in parallel. After we get the answer coming as they done by creating those codes. And how do we gather those 3 codes if they're made in parallel? In the next node, what we do, we just get the 3 last messages. Generally, the Genma one will be picked because it's the one that is coming back the quickest from Grok. Validity, yes. So here we are judging the code. So we are checking the scripts if they are well indented, they have the good imports, there's no missing parenthesis or string not closed properly. Here is validating all the codes. I'm using here structured output in another way because I'm putting the schema directly into the prompt. Validity, yes, and is giving the reason also. So code evaluation. Evaluated geometry as yes. You see here the code retry validation is at 9. So in the code generation, it's better than in the document generation. That's why I had to ask documentation to be in a JSON output. Sometimes we get some errors because it can include some code in, and when there's some code in, it's going to forget to escape some characters, which is going to not be JSON serializable. And that's how I'm passing from one node to another. Same, I'm going to talk about this at the end. And here we get the choices. We get the names. So we're using all those names after to create the files. So it has picked one code. The reason all 3 scripts are identical in functionality and perform the API call to get the edge of a friend chosen Genma are arbitrary since all scripts are the same. So it just picked one out of those because they're all the same. So because we use structure output maybe on the same schema, they're all returning the same kind of code. Choose code to execute. So we've seen already the answer before. That's Genma has been chosen. Okay, so here we provide the code, we provide everything because we want the requirement to be created. Are the requirements needed for this code? Yes, it's needed. And here we need the request. And this is the request requirement. And from that, the file is going to be created. Request yes. And we put it in a Docker agent folder. Scripts. Genma, we put the name and the requirement.txt here. Create requirement for code. And we got the path and the LLM name saved in the states. And after the Docker agent, the sandbox is going to start creating this Docker file. Here, this is the Docker file. We can't really see it here. I don't know if I'm going to copy it for you to see it somewhere else. And after here, we get rid of it. So we delete the image. So image sandbox Python removed successfully. And here the code execution node returns standard output, which means it's a successful. With more details. So I'm using a lot of JSON to just capture as much as I can and pass it. And we get here the success with here the answer. Successful code execution management. And after we just go to the intergraph node. Nice. We got that running nicely. So -1 message, -2. I'm just returning the 3 last messages just to have some little context. For the next node or So ignore the end. It's from the previous videos. So now success for the dog also. Let's put here, I need to have some dog images using API call. Can you help? Or I'm going to be more explicit. It's good to put in your prompt actually what you really want, what you really don't want. So this has helped me to lower the error rates. Can you make the script for me? Making sure that it's executable and uses Python standard libraries, as I'm not good in coding. So I trust you to make it without any error. So I say without any error, but I wrote with a 2, any error of indentation, missing parenthesis, string not closed. So that's the errors that you're gonna get from a small model or any other. Respect output format strictly. So yes, this also, it's an issue. After the code is gonna run, we're gonna let it run, and we got an error. You see, it has stopped at the step number 9, documentation, step evaluator, and doc judge. And here we got an error, a key error. So this might be in the code. So we're gonna take the query, the same query, just copy it and relaunch it. So hoping that this time it doesn't escape those brackets. Okay, we have passed that step number 9. Code has been generated. So don't worry, we're going to go back and see all the different steps. So stay to the end. We'll be able to see this dog image, which kind of dog we're going to get. Okay, here it's successful. Okay, we got rid of the image. So let's go back to where we got that error, and we have relaunched the graph. Let's go here. Okay, we got our prompt. A nice prompt with detailed request in the prompt, asking to not make any errors. Maybe the respect output format strictly. That's why it has escaped the answers. So this is good. That's what I want. But I have to manage it better in the code. So there's also, my code is not perfect. There's also that variable. Okay, so we choose duck images because that's what we want. After, I'm just going to create this schema for the tool to be able to use that. So that's what has been chosen. We're going to search in internet. So it's going to use here the same request, how to make an API call, get a response. It's a very important part. Error. So we got an error here. Rate limit exception. DuckDuckGo. Please fix your mistakes. So here it says error, but we got an output. So it's okay. But probably it has taken the output from the previous run. That's why it didn't stop. But you see, you can get also the different API you're using not working well like a DuckDuckGo. So you need to find a more consistent one, stronger API. So you need to pay at one moment to have something perfect. Here we go. So we got the documentation being created. We tried the validation, still at 7. Okay. So the error wasn't coming from the escape because we got the same answer. So if you have spotted why we got the error before, just comment. And here we got the code created by the different agents using all different models to make the script. So maybe what I haven't implemented in this graph is some sleep time sometimes to not get the grok rate limits. But for the moment it's okay. I haven't I've been stopped by that. So we didn't need to retry. So I might need also to improve the code in the loops. Here we good. We got the code. It has picked Genma. Usually picks Genma first because of the alphabet maybe. While Yama is a L. And it's always returning a valid code. So all the screen perform the same task, which makes it easier to execute without having the function. This is useful for users who are not familiar with coding and just want to run the script on the dog image. It's good to have a reason just to know why it has selected that code. We got the result. We got the requests in the requirements. And after we got the execution by creating first the Docker image. And here we got that. So this one has run standard output. You see the standard error here is empty. The exception is empty. So I'm trying to capture those ones. And depending on if those ones are empty or not, it will trigger a retry. And here we got the image. So we might need to check it online. Let me open the browser. Yes. Let's put the link and see what we got. Oh, nice. Almost a Shiba Inu. But it's not. It's a Chihuahua? I don't know what it is. Just tell me in the comment section. Success jokes. So here we are using the third API by triggering it. I'm not very funny guy and want to use some jokes during the next very serious meeting. Can you make a Python script? After I put the requirements asking for that, and it's going to be running. So as I'm improving my code, I got less errors. So some errors are coming from me, not from the LLM because it's small. But I'll talk about that at the end. There'll be a part of my talk talking about that. And here we got the script made. This one runs pretty smoothly, a little bit better. Okay, the Docker is starting. You see it's pretty quick, even if you get all of those. I'm trying to print the graph image, but I get an error with the graph image. So the graph image that you keep in your mind is the one that you have created initially. Why did the butcher work extra hours at the shop? So why? Punchline, to make ends meet. Okay. So this is the joke. I don't believe it's gonna work during the serious meeting. And I don't suggest you to make any jokes during serious meetings. This is just for the tutorial here. So we got our query. Okay, during the serious meeting, can you make a Python script that calls an API to get jokes? It will be formatted, well indented, and using only Python standard libraries to make it easy for me to execute. Same kind of sentence. After we're going here, we're using the structural output, which has detected that we have a code request. There's no document, nothing like that, no PDF, no URL. So we return code here, which is going to trigger the graph to start all the other nodes. Okay. After here, we have the tool agent, decide which API to call. It's empty, so there's nothing here. So you see here, it didn't detect, but I mean, it did detect, but it didn't use the tool. I have a tool called joke, but it didn't use it. I will use the joke tool. So it's just going to use directly the link and make the code. So that's what it has decided here to do. Or maybe it has used the tool, but we didn't get any output. Because the tool is outputting actually only the name of the API that we want to use. So tool search node, we go online. This time we don't get any DuckDuckGo error. Okay, so I said to not put the code in the documentation, but we can see the code coming back again and again, but it's okay. Okay, those are the steps in the documentation. So the document writer has written all those different steps. So I didn't tell him to use Markdown, but it has used Markdown. So I could have had an error here because of that, but it was okay because he could structure it in a good way, a good JSON, valid one. Success generate. That's good. So here I just put the retry back to 10, and we didn't need to retry at all. For the code execution, it goes smoothly. Response. All Yama 70B. We got the 8B before, and we got Genma. We got the codes all made in parallel. We're capturing those codes from those 3 LLM names, and we put it in a JSON format, sending it to the next node, which is going to choose which code we are going to execute. Validity, yes. So what does it say for the reason? Yes. Okay. So where is it? Evaluation, yes. Reason. The script is well formatted, indented. Okay. Evaluation, conditional edge. So we're going through the same steps that we went before. Speaking the first code, which is the one, is Genma. It's always valid, and is starting with a G in the alphabet order. So that's the one which has been picked. All 3 scripts are identical in functionality and formatted well, but since the requirement is to choose one, Genma CVNTB has it presented first. You see, it just said it by itself. So it's not even alphabetic, it's because it has been presented first. That's good. And after the Docker creation, choose code or execute. So we pass that step. We create the requirements as before. As pick the same. The requests, that's what we need. We ask for standard libraries, but we need requirements at one moment. And this is a minimal requirement, just to make an API call. Okay, and after here we're going to be running this script. And you've seen already the output. But here we get the Docker execution. Just going to copy this. Let's go here. I just want you to see the Docker, how the Docker file is made. For the steps, where does it start? So here, build, Genma, load, Docker ignore, here. So here we get the image. It's a Python 3.9 Slim that we get. After we copy the file to point to here, we run the pip install directly on it. We got the requirement installed. We copy the script .py inside the folder app with the same name. We move to the working directory app. Okay, and from there we're going to just run the command, which is not written here, but the command to run it actually. So Python 3, and we run the application. And after we delete the container, the image also, we just delete everything. The container is running, is leaving just while it's running. And after we got our answer. So this is how you can customize and have control on all the steps using your own code. Here I'm trying to print the graph. It didn't work. I changed the method several times. Here it says draw PNG. It didn't work. So I need to fix this, or I need to not print it at all. And just use the schema that I drawn. So I'm just going to comment it out. So you see, I used to use the Draw Mermaid PNG with the X-ray to true, but they might have an issue with the API. I don't know. It is not printing the graph. So let's go through the folders very quickly. Here's the agent folder. The agent scripts has been created. This is the code, well indented, nice imports. After all the comments above, I've just put them on the top. We have the requirements. Is here the requirements with the name of the LLM. Maybe you might be interested in seeing, where is it? The Docker file, and that's the Docker file that you've seen before with the last command down there, Python, and after we just run the script. So I have separated everything in different folders, the tools, the states, and the structured outputs. But if you're still here, just listen at my feedback around this playlist and everything we've done. So it's feedback time. From my experience, consistency is not satisfactory. As the first node get errors sometimes, on average issues and how LLM return the answer with some errors, syntax, so making it inconsistent to pass. So this runs to the end, but it will probably fail if the retry loops were involved, as sometimes we get answers not properly formatted by the LLM. So retrying will increase the probability to get those coming. So here it is a very raw code for the example of this tutorial, but out of the experience that I gained doing this, I would say that it needs to be implemented very, very strong error handling, which are not just throwing errors, but acting depending on what are those errors. So you don't want to break your app or just stop everything because there's an error, but you want to just handle it and do something else. This could be an idea for real utility of agents, actually, to figure out errors and find the remedies or suggest remedies that they can act upon. Also, when having such a long graph, we need to test each node independently and each function as well. I've said it before, but it's very important. We need to have a mapping of what are the types returned, the types of values returned at each node, or work on a policy that says, for example, we will return in this way consistently to have the node's output being captured properly by the next node. In here, I found that using dictionaries and using JSON dumps and JSON loads helped to have more complex objects being passed from one node to another. For structured outputs, got a lot of issues because of the small LLMs, but I believe that with huge models leading the market, it would be much more easy and more powerful. But as I said, we use small models to find a system, something that works, before going into paying ones. Then when using paying ones, incrementally improve through development cycles. So in your agility, you just keep improving, but you need to fail fast for that. So how would I use those agents? Not my whole app running on agent. So I would say just forget about that, but just few subsets, adding value to to what would run using those actually, just for specific tasks, user-facing or just on the backend, like having an agent managing the app logs, for example, to format those logs and notify other agents that would take some different actions, or notify some human by suggesting them how to manage the error, for example. So this is an example that can be considered in how to use agents. So just a subset of an application, or working on the backend. So you can use asynchronous. You can also have errors and handle those errors. So there's no impact on the user. It's more internal. Draw, and draw again. I realized that drawing your system in a high level is pretty important, and then going further down the line to some specific parts helps a lot. AI is very helpful for people who have a kind of project management thinking processes on the systems. The theoretical part now can have more value as the prompting becomes the center of the future of application development. The code side will be slowly streamlined to AI computers that would use their own abstraction to translate that to functions and zeros and ones. So maybe something that we can't even understand, but we will be just prompting. In this project, I have seen significant changes while changing the prompts. I can say that this was always failing at the beginning, but just changing the prompts, now it runs fine with small LLMs, 7 to 8 times, I would say, closer to 7 times every 10 runs. So from the beginning to the end, it will run without any error. Also, out of my own coding errors that I have fixed along the way, errors coming from the LLM output structure, that was the biggest issue. So, for example, you see OpenAI now has provided in the API a way to structure the output. So you understand why this is important, is because that's where people struggle. So it accelerates the development and testing. I would say bigger LLMs would have nailed it. That's what I believe. But let's stay in the free zone while Grok. Stay in the free zone with Grok, which is helping us test more easily, even if we get some rate limits. Grok has helped a lot to accelerate the development, testing, and experiencing of LLMs. So it has helped to fail fast in order to improve quick. This to say that model inference speed is crucial, as we don't want to wait too long to get an answer. And also output structure consistency. We need to fail fast. That's what we need, and gather this experience. That's why you need to build your own graph. You need to go through the documentation, and you use those videos as an example of what had worked before, because the documentation is changing also incrementally. Why LangGraph? Why did I choose LangGraph? It is because, unlike the other agent framework, which are or wrapping of LangGraph, or they have their own framework, we have more control of what is going on, and understanding what is going on is important on your code. Therefore, it's easier to specialize and customize to different clients' needs. Yeah. Okay, we're gonna stop here. We are done with this LangGraph playlist. So thank you for your support and for people who have watched it to the end. Hope that you could navigate through the documentation easily and could get to understand the parts that you needed for your agentic system. Please like and subscribe, and see you next time.